Hello बच्चों, let's read this question. Question says standard Gibbs energy of reaction del Rg at a certain temperature can be computed as del G is equals to del H minus T del S, and the change in the value of del H and del S for a reaction with temperature can be computed as follows. Here that enthalpy of reaction, change in enthalpy of reaction at temperature T2 minus change in enthalpy of reaction at temperature T1 is equals to del RCP, that is change in heat capacity at constant pressure multiplied by T2 minus T1. Here del ST2 minus del ST1 is equals to del CP ln T2 by T1. Del GR is equals to del H minus T del S, and del G is equals to minus RT ln K equilibrium. Consider the following reaction: CO gaseous plus 2H2 gas is in equilibrium with CH3OH gaseous. Given enthalpy of formation of CH3OH gaseous is equals to minus 201 kilojoule per mole. Enthalpy of formation of CO gaseous is equals to minus 114 kilojoule per mole. Here entropy of CH3OH is equals to 240 joule per Kelvin per mole. Entropy for H2 gaseous is equals to 29 joule per Kelvin per mole. Entropy for CO gaseous is equals to 198 joule per Kelvin per mole, and the CP, that is molar heat capacity at constant pressure for H2 is equals to 28.8 joule per Kelvin per mole, and molar heat capacity for carbon monoxide is equals to 29.4 joule per Kelvin per mole, and molar heat capacity for CH3OH is equals to 44 joule per Kelvin per mole, and ln 320 divided by 300 is equals to 0.06, all data at 300 Kelvin. We have to find out change in entropy of reaction at 320 Kelvin. Is options are 155.18, 150.02, 172, and none of these. Now we have to calculate. So firstly, this is the given data. We have no need to write it again. So now at 300 Kelvin, the data is given. So we can calculate at 300 Kelvin change in entropy of reaction. This will be our key concept here in this key concept. So this is at 300 Kelvin. We can calculate that summation of entropy of product minus summation of entropy of reactant. Now we can substitute the values. So the values are at product side, here CH3OH is present and the value is given 240. So 240 minus here for reactant side, here CO and 2H2 are given. So the value for CO is 198 and for H2 it is 29. So 2H2 are present. So we can write 2 multiplied by 29. So overall the value comes out to be minus 16 joule per Kelvin per mole. This is the value of entropy at 300 Kelvin. Now we have to calculate for 320 Kelvin. So we can write our formula, that is change in entropy of reaction at 320. It is equals to change in entropy of reaction at 300 plus the value is here del RCP, that is change in molar heat capacity at constant pressure ln T2 by T1. Here T2 is 320 and T1 is 300. Now we can substitute the values here. So firstly we will calculate the value of del CP. So the del CP naught can be calculated as summation of CP at product side minus summation of CP at reactant side. So we can write at product side, here CH3OH is present, so the value is given 44, minus at reactant side, here carbon monoxide, that is 29.4 plus for hydrogen it is 28.8. so we can write 2 multiplied by 28.8. so the final value comes out to be minus 2. This value comes out to be here 44 minus, we can add this value. So here 29, here 29.4 plus here it is 57.6. Now we can add this. So the value comes out to be 44 minus it is here 0, 7 and 87.0. This comes out to be minus 43. This is the value for CP and the unit is joule per Kelvin per mole. Joule per Kelvin per mole. Now we can substitute the value in this formula. So we will get that standard entropy of reaction at 320 Kelvin. We have to calculate for 320 Kelvin. So here it is 320, it is equals to the value for 300 Kelvin, it is equals to minus 16 plus. Here the value of del Cp, it is equals to minus 43. So minus 43 ln T2 by T1. T2 is 320 minus T1 is 300. Ln T2 by T1, that is 320 by 300, it is given as 0.06. So we can write that it is equals to minus 16 minus 43 multiplied by 0.06. So the final answer, that is entropy of reaction at 320 Kelvin, comes out to be minus 18.58 joule per Kelvin per mole. Here the options are not matching, so here option D, that is none of these, is the correct choice for this question. Hope you understood it well. All the best and thank you.